In continuation of chemistry lectures, today I am going to explain what is covalent bonding. During covalent bonding, sharing of electrons takes place between atoms. And remember that covalent bonding exists among non-metallic elements. For example, hydrogen, for example, oxygen, water, carbon dioxide, methane gas, ammonia, all these are covalently bonded. Let me tell you that and let me remind you that ionic bonding exists between metals and non-metals, and in ionic bonds transfer of electron takes place, whereas in covalent bonding sharing of electron takes place, and the atoms they share their electron in order to complete their outermost shell. The ultimate goal and the ultimate objective of all types of bonding, either it is ionic bonding or it is covalent bonding, the ultimate goal is to complete the valence shell. So the atoms they form bond to complete their outermost shell. In case of covalent bonding, here sharing of electron takes place, and in this way the atoms they complete their shells. And as a result of covalent bond formation, the molecules are formed. As a result of covalent bonding, molecules are formed. So it means that for covalent bonding we use the term molecules. Now molecules, remember, are of two types: molecules of elements and molecules of compounds. As you know that elements are composed of similar kind of atoms. In elements, all the atoms are of same kind, are of same type, while in compounds the atoms are different. There are different elements, different types of atoms, they are combined together through chemical means. So therefore, keeping in mind this difference of element and compound, so molecules of elements will be having same type of atoms. For instance, hydrogen gas is a molecule H2, and in hydrogen molecule both the atoms are similar. Both the atoms are of hydrogen. For instance, this atom is also hydrogen atom, and this atom is also hydrogen atom. And we will represent the bonding by dot and cross diagram in order to differentiate that. For instance, if this and remember, for instance, that hydrogen is its proton number is 1. When its proton number is 1, it means it has 1 proton and 1 electron, and this electron is present in this shell, in the first shell. For instance, I am representing this dot. This dot is representing the electron of this hydrogen, while the other atom, the other hydrogen atom, its electron will be represented by cross. Just to differentiate, dot and cross diagram is drawn and is shown. So when one electron, which is here in the form of dot, it is belonging to this hydrogen, and this cross electron, this is representing, and this is belonging to another, this one hydrogen. So these two hydrogen atoms, their orbits overlap, they come closer, and now it forms a pair of electron. Now two electrons are there, one electron of this and the other electron of the second atom. So the two electrons, as the first shell we know it needs 2 electrons to complete the shell. Now the outermost shell is complete for both of the hydrogen atoms. For both of the atoms, the hydrogen atoms, the outermost shell is complete. There, for this hydrogen, there are 2 electrons, and for this hydrogen, there are 2 electrons. And as the first shell needs 2 electrons, so both of the atoms, they got stable. Their outermost shell, their valence shell is complete, their valency is satisfied, and in this way hydrogen molecule is formed. And remember, this is single covalent bond. Single covalent bond means that one electron is being shared, one pair of electron is formed. If one pair of electron is formed, this is called single covalent bond. On the other hand, oxygen atom, when 2 oxygen atoms are coming closer, remember that the proton number of oxygen is, here I am writing, suppose the proton number of oxygen is 8. It means it has 8 protons and 8 electrons. And what will be the distribution of these electrons? What will be the electronic configuration of oxygen? In the first shell there will be 2 electrons, and in the second shell there will be 6 electrons. So oxygen atom contains 6 electrons in the outermost shell, in its valence shell. Now I am drawing 6 electrons for this oxygen. This is suppose one oxygen atom, and it is having how many electrons? 6 electrons. 1, 2, 3, 4 and 5, 6. I draw 4 electrons separately and 2 electrons I am drawing in the overlapping region, because these 2 electrons will be involved in sharing, will be involved in covalent bonding. Now I am drawing 6 electrons of the other oxygen. This is another atom of oxygen, and it is also having 6 electrons in the valence shell. Once again I will repeat that the proton number of oxygen is 8. So it means it has 8 protons and 8 electrons. And as it has 8 electrons, so what will be the electronic configuration? In the first shell it is having 2 electrons, in the second shell it is having 6 electrons. Now I am drawing the 6 electrons of another oxygen, the second oxygen atom. 1, 2, 3, 4, 5, 6. And here I represented the electrons of this oxygen with cross. So dot and cross diagram, just to differentiate. The electrons of this oxygen are being represented by dot, and the electrons of second oxygen atom, they are represented by cross. And now let's count how many electrons are total. 1, 2, 3, 4, 5, 6, 7, 8. It means that this oxygen is having now 8 electrons, which is required in the second shell. Second shell needs 8 electrons to complete. So its outermost, its valence shell is complete. Similarly here for this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So its outermost shell is also complete. Both oxygen atoms, their outermost shell got complete and they got stable. So this is the case where I am saying that covalent bonding is existing among molecules of element. For example, molecule of hydrogen, for example, molecule of oxygen. Now come to molecule of compound, that how covalent bonding will exist in compounds, and how covalent bonding will result in molecules of compounds. For instance, molecule of water. The formula of water is H2O. Now as we know, as I mentioned now, that oxygen is having proton number 8. So it is having 8 protons and 8 electrons. And how many electron will be there in the first shell? 2. And how many electron will be there in the second shell? 6 electrons. Now I am drawing 1, 2, 3, 4 and 5 and 6. This is a specific arrangement. Now 4 electrons are not being shared. They are unshared pair of electrons, and the shared electrons are one here and one here. And now two hydrogen atoms will come, and they will form a covalent bond with this oxygen atom. This is oxygen atom and these two hydrogen atoms. And as we know that hydrogen, its proton number is 1, and when its proton number is 1, it has 1 proton and 1 electron obviously. So 1 electron is there. Now this 1 electron, how it will be arranged? That this 1 electron is here, and this is for hydrogen. This is for another hydrogen. Second hydrogen will come here and this electron will be here. Now keep in mind that 2 hydrogen atoms and 1 oxygen atom, they are forming a covalent bond and they are sharing the electron. Now what happens that hydrogen is very simple atom and it has only one shell, first shell, and first shell needs 2 electrons. Now 1 electron of its own and the second electron of oxygen. So 2 electrons, so hydrogen, its outermost shell got complete. Similarly here, this hydrogen, its outermost shell got complete. 1 electron of this oxygen and 1 electron of hydrogen itself, so it will form 2 electrons. So this hydrogen atom got duplet, its first shell completed. Here it's also first shell completed, while in case of oxygen 1, 2, 3, 4, 5, 6, 7, 8. So oxygen 8 electrons are completed. Its octet rule is followed and satisfied. Then in this way H2O is formed, where all the 3 atoms, they got their valence shell complete, their valency is satisfied and they got stable. In this way H2O is formed, which is a covalent bond. Sharing of electron is taking place between non-metals, between non-metallic elements. I repeat. Similarly, let's take another example, methane. Methane is a gas. Its formula is CH4. How? They are arranging to form a covalent bond. In the center there is carbon atom. Remember that carbon, its proton number is 6. It means it has 6 protons and 6 electrons. And what will be the arrangement of electron? What will be the electronic configuration of carbon? Because it is having 6 electrons. So first shell 2 and second shell 4 electrons. It means that carbon has 4 electrons in the valence shell. Now I am drawing these 4 electrons. 1 electron, 2, 3 and 4 electron of carbon. Now I am drawing I am considering hydrogen atoms. So 4 hydrogens in case of methane will come and they will form a covalent bond with carbon. 1 hydrogen will be here in this corner, second hydrogen will be here, third hydrogen will be here, and fourth hydrogen will be on this corner. And as we know that proton number of hydrogen is 1, it has 1 proton, 1 electron. Now I am drawing this 1 electron. Suppose this electron is represented by cross. 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 So because we are representing the electrons of carbon by dot, and we are representing the electrons of hydrogen by cross. This is called dot and cross diagram. Now 1, 2, 3, 4, 5, 6, 7, 8. Carbon 8 electrons are completed. Its valency is satisfied, while hydrogen 2 electrons are completed. Hydrogen 2 electrons, first shell is completed. Hydrogen 2 electrons, first shell is completed. Hydrogen 2 electrons, first shell, and the duplet rule is followed. In this way, all the carbon and hydrogen atoms, their outermost shell got completed. How? By sharing of electron, by forming covalent bond. So, in covalent bonding, sharing of electron takes place, and in this way, atoms complete their outermost shell and they get stable, and either they form molecules of elements or molecule of compound. Now let's consider that how the covalent bonding, it affects the properties of the covalently bonded substances. When the substances, either these are the elements or compounds, they are formed through covalent bonding, so they have certain properties, and these properties are that they have lower melting and boiling points. Why they have lower melting and boiling points? Because they are covalently bonded. They do not have ionic bonds. In ionic bonding, ions are there. Electrostatic forces of attraction are there in the case of ionic bonds, and there are strong electrostatic forces of attraction. But in covalent substances, there are no electrostatic forces of attraction. When the question is asked in the exam that why covalent compounds have lower melting and boiling points, so you will say that there is no electrostatic force of attraction existing between positive and negative ions. There are no positive and negative ions. Just sharing of electron takes place, and because of sharing of electrons, there are weak intermolecular forces. They have lower melting and boiling points. For example, water. For example, oxygen gas. Its boiling point is in minus. Its melting point is in minus. It is about minus 186 degrees Celsius. Similarly, boiling point of water is just 100 degree, and its melting point is 0 degree centigrade. Why? Because of weak intermolecular forces. So there are no electrostatic forces of attraction. There are no forces of attraction, strong electrostatic forces of attraction, as it is in case of ionic compounds. There are only weak intermolecular forces. This is the reason that why covalent compounds have lower melting and boiling points. Why they have lower melting and boiling points? Because of weak intermolecular forces. Second property is that covalently bonded substances are non-conductor of electricity. Once again, the reason is that there are no ions, and as there are no positive and negative ions, they are neutral, they cannot carry charges, and they are non-conductor of electricity. So that's how we can relate the properties of the covalent substances with their bonding, and that's how we can link the bonding with their properties. This is asked in the exams, so you must keep in mind. So this was about covalent substances and covalent bonding. Thank you.